solving equations, graphing, numerically, and algebraically. First example, they have a line that's graphed, and they're using the trace feature. They're just tracing a line, and they're seeing where does it stop when it's on the x-axis, because that's when y is 0. That's an x-intercept. When x is a number and y is 0, you're right on the x-axis. Those are very important in mathematics to be able to find x-intercepts. I'm sure you guys remember that from Algebra 1 and 2. So they just used the trace button and stopped until it said 0. And they said, okay, 2.5 is a solution of the equation then. 2.5 is a solution of this equation. They're using a graph to be able to solve. I just showed you the algebra that you've done forever on two-step equations since junior high school. And I know that you guys are really good at solving equations because I haven't seen any issues with solving. So we're going to go to y equals. It always has to say y equals, clear out anything that might be in there. Y equals, example 1, 2x. It's right here on the left, x squared. We're going to graph. My window's all messed up. So I'm going to go to zoom. My window's messed up. So if I go to zoom, I want to change it back to a 10 by 10. I want my x to be 10 and negative 10. That would be number 6, standard zoom. Number 6 brings you into the main graph. And if you can't see something from there, then you would adjust it more. All right, so I can see everything that I need to. What am I looking for right now? I'm trying to solve. When we're trying to solve an equation, what are we actually looking for? We're looking for the x-intercepts, right? When we're solving an equation, how many x-intercepts does this picture have? It has 2. It has one right here, and it has one right there. So we need to trace, and we're going to use the trace feature, which is right here, trace next to graph. We're going to just trace it until on the bottom it says that y is 0. When it says that y is 0, I know I'm right on the x-axis. And it kind of just jumps right over it, doesn't it? Does yours? Yeah. Yours jumps over as well. From -1 to yeah. Let me just show you how to actually calculate the zeros. We'll go right to calculating 0, okay? The calculator is still going to do the work. So we're going to go to trace, and then above trace is calc. That's the button that we want to go to. We want to calculate number 2, a 0. That's how to get to where we're going. You go where the trace button is, you go above that, it's in blue. Calc. And then it says go to number 2, 0. Calc. All right, the thing about doing zeros is it doesn't just come up. You have to remember that a calculator is about infinity. You have to tell the calculator what to do. So if you don't know how to tell the calculator what to do, then the calculator is pretty much useless to you. So I go to calculate. Number 2, I want to calculate a 0. Well, you have to do it twice because there's 2 zeros. And only calculate 1 0 at a time. Let's scroll over to the left. So my cursor is over near the left-hand side. Right now, it's asking me for a left bound. The calculator needs bounds. It needs a left bound. I need to be on this side of it. Where am I going to be on this side? Here's my x-intercept. I need to be on this side. Do I need to be on top of the function or on the bottom of the function to be on the left side? That's what it's asking me right now. Give it a left bound. So if I look at this right here, here is my intercept right here. Well, look above it. That's on the left-hand side of it. What's on the bottom? I'm on the right-hand side of this x-intercept right now. I'm on the right of it. Right now where I am, if that's my x-intercept, I'm on the right side of it. I'd have to be on the top part to be on the left side of it. So I go over to be on the top. That tells me now that here's my x-intercept. Where's my cursor? My cursor is to the left of this x-intercept. Once you're on the left side bound, you hit enter. And now it's going to ask for a right bound. So what do? I scroll over and I go down to the bottom. I'm on the bottom of it. Now my cursor is on the right-hand side of that x-intercept. You've got to give it a left side and a right side so it can look at the arrow up here. This arrow popped up. See that arrow? That arrow says, I am a calculator and I'm going to start right where this arrow is to start looking for your 0. When I hit enter again, another arrow comes up. There it is. Here's another black arrow. The calculator is saying, I am going to look between these two arrows for that x-intercept. That's why you got to give it a left and a right. Then you hit enter. There it is, negative 0.5. So the first one is x equals negative 0.5. Now my cursor is asking for a left bound. The question is, where am I going to be the left of this x-intercept? Am I going to be on top to be on the left, or am I on the bottom to be on the left? Right now you need the left side of it. Here it is. Which part of the picture is on the left-hand side of that? The bottom is on the left-hand side of it. So now the bottom becomes the left bound. So I just make sure that my cursor is over here, closer to it on the bottom, enter. And you can see that little black arrow comes up on the top to let you know that's where it's starting. And now I need to go to the right bound. So I'm going to go up here where it's going to be on the right side. Hit enter. I'm looking. Yeah, it looks like it's in there. Hit enter. And you get 2, 0. X equals 2. X equals a half. All right, so that's how you would solve it graphically. I wouldn't even use the trace feature. I'd be like, I'm going to use the trace. I'm going to use the calc button. But you know that trace is there anytime that, yeah, and I might go like this to say I'm not going to probably use the trace button too much. There was another way we could have found out what those intercepts were. If I'm looking at my graph and I know, I mean, you're really close to 0 on both sides, I could have gone to my table of values, table, and it's starting at 59. I don't want it to start there, so table set at 0, and I just want to go by integers. 1. You're looking for when y is 0. You could look at your table of values. Here's y is 0 at 2. Remember, table set, and I want to set my table not at 0. I'd have to set it at like what, -5, and then go 0.1 for 1 decimal. Look at my graph at any time and say, where's that picture? That picture is close to 0 on the negative side, and there it is, negative 0.50. So you have your table to manipulate where you want to look at. Here we have the quadratic equation. That's pretty important. Ax squared plus bx plus c. There's the quadratic. How is the quadratic different than linear? Exactly. So linear would be y equals x, and quadratic, the degree has gone up. Now it's y equals x squared. That's the difference so far between linear and quadratics, is the degree of the problem. Looking at this problem, I wonder where I would have to start first. Okay, so the thing about I think where you're going right now is you might be thinking about this, right? You said parentheses first, so this just made me think of that. Were you thinking of this when you said that? Okay, so for PEMDAS, when you simplify expressions, you are going forward. What about when you're solving? You have to go backwards when you're solving. Everything has an opposite. Simplifying goes forward, solving goes backwards. Is there any adding and subtracting? But what? Yes, but where is the adding and subtracting? It's in the parentheses. So technically that would fall into parentheses then. You can't go into parentheses. If you had adding or subtracting on the outside, then you could do it. So there's no adding and subtracting yet to do. What about multiplying and dividing? Where's the multiplying and dividing? That would be next. So there's not like a 3 being multiplied to the parenthesis, right? No number of variable out here. So the first step is the exponent. You have to do the exponent first. I can't do subtracting because it's in the parentheses. That falls under the last step. What's the opposite of squaring? Square rooting. Square and square roots are opposites of each other. Remember, there's a 2 right here because it's a square root. Those are opposites of each other. So a square root undoes a square, and a square undoes a square root. So we have to square root this side, and then we have to square root this side. But we have to remember something when we square root. How many answers does a square root have? It has 2 answers. So really that is plus or minus the square root of 9. And that does undo this right here. It leaves just 2x minus 1 equals plus or minus what? 3. So we're just going to continue. We add 1 to both sides. So we have 2x equals 1 plus or minus 3. But you could simplify this first if you wanted to. What's 1 plus 3? 4. So I would have 2x equals 4. And what's 1 minus 3? What's 1 minus 3? Negative 2. So you have 2x equals negative 2 as well. You end up with 2 different answers. I could have also done what you said and just divided here. And you still have to simplify this. X equals, and we'd get the same thing, 4 divided by 2, and x equals negative 2 divided by 2. But you see that here as well. Divide by 2, divide by 2. You have 4 divided by 2. It just depends on how you want to do it. But you do have 2 separate answers. X equals 2, and x equals negative 1. Leading coefficient doesn't equal a 1. Here's my leading coefficient. If it doesn't equal a 1, then you have to divide both sides of the equation by 4. Divide by 4, divide by 4. I'm going to say, okay, need a 1 for coefficient. If you have a 1, you don't have to do this step. But if you don't have a 1, then you have to divide it out from both sides. How did they go from this step to the next step? What happened on that? How did I go from this step to getting my answer here? They did. 4 divided by 4 is 1. Now I have that 1 that I need. Then they had negative 20 divided by 4. Negative 20 divided by 4 is negative 5. And then 17/4, nothing happened to it. 0 divided by 4 is 0. So they divided all the 4 terms here by that 4 and simplified when possible and left it as a fraction when it wasn't possible. All right, that was step 1. Step 2 says to isolate the x terms by shifting the constant to the other side of the equation. This is the constant. So I would have x squared minus 5x. I'm going to leave room to complete the square, and I'm going to put 17/4 on the other side. So if you have another highlighter for a different color, you could say that step 2 was about isolating the x terms. So that's x squared minus 5x. Isolating them. All right, the next step would be to make a quadratic square trinomial by halving the b term and then squaring it. That's what this means. Half it and square it. We need to half the b term and then we have to square it. And we need to add that to both sides of the equation. So I need to half it and then I need to square it. So what is half of negative 5? It's negative 5 halves. It doesn't work out evenly. There's halving it. Half it. And then we're going to put parentheses around it and we're going to square it. So the negative 5 is b. Negative 5 is this b term right here. Negative 5 came from b. We have to half it and then square it. So what's negative 5 times negative 5? It's a positive 25. And what's 2 squared? 2 times 2 is, so that's, we're just adding 25/4 to that side, and then we've got to add 25/4 to this side, and my 17/4 should be negative because I put it on the other side, minus 17/4. Did you guys put negative there? All right, this is a perfect square trinomial. Where does it say that? Perfect square trinomial. This is, believe it or not, it's a perfect square trinomial. That is a perfect square trinomial because all I have to do is take this term, negative 5 halves, go like this. X minus my 5 halves squared. That's what it would look like factored. 25 minus 17 is 8, and then you have fourths. Dividing, no, we start with the exponents. So we're going to undo this with a square root. And we're going to undo this side with a square root, and we're going to say it's plus or minus the square root of 2. Plus or minus the square root of 2. So we have x minus 5 halves equals plus or minus the square root of 2. And then we just need to finish solving by adding 5/2 to both sides. X equals a positive 5/2 on the right, plus or minus the square root of 2. All right, so on my calculator, how am I going to find my two answers? It says plus or minus. That means that there's two answers here. It's a degree 2. A degree 2 is always going to have two answers. Unless, I'm using parentheses. 5 divide 2. That's what 5/2 is. 5 divide 2. And we'll start with plus. Plus the square root of 2. The square root is on the same button as the square. I wonder why they would put it there. And the square root of 2. And then arrow out from underneath of it. Then you push enter. Enter. And we get 3.91. So x equals. It says entry. That means I'm in blue. If I push it and I push entry, it brings back my last entry. I don't have to punch it all in again. Then I can just arrow over and change it to a minus sign. All right, you guys get 1.09. All right, so there's the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. And where are we getting the a, b's, and c's from? From the quadratic. Ax squared plus bx plus c equals 0. All right, here we go. What's a? What's b? And what is c? A is 3. B is -6. Always keep your signs in front of your terms. And, I wonder what C is. Now, we need to actually make sure that it's set equal to 0. Otherwise, we won't see everything correctly. So that's 3x squared minus 6x. If it's a positive 5 on the right, what's it going to be on the left? It's going to be a -5 when I shift it over to the left, equals 0. And now I can clearly see that my C term is -5. All right, we're just substituting into the quadratic formula. It says negative b, and b is -6. I'm just putting it in there for my notes so that I know when I look back at my notes that I didn't just put 6. So negative b plus or minus the square root of, this is an area where I constantly see students get b squared wrong. It says all of b needs to be squared. So if I just put it in here like this, that's not all of b being squared. What is being squared on this exactly? Just the 6, because the 6 is the only thing next to the square. How do I make it so it includes the negative? It's got to be in parentheses so that everything in there is being squared. So we had b squared minus 4 times a times c, -4 times a times c, and then all of that over 2 times a. Then you just start to simplify. And this is x equals that. X equals positive 6 plus or minus, what's -6 squared? Positive 36. -6 times -6 is 36. Then I'm looking at 3 numbers being multiplied together right now. That minus sign is part of the 4, -4. Negative times a negative, I've got 2 negatives. I know my answer is positive then. Over 6. So we have 6 plus or minus the square root of 96 over 6. X equals this. I guess I'm going to have to show you this as well because it's a fraction. So when you're on your calculator, you got to remember to keep things grouped together. That means that this numerator needs to stay grouped together on your calculator. Calculator has to stay grouped together. Otherwise, you will not get the right answer. There's more than one term in the numerator. If the denominator had more than one term, you'd have to put parentheses there as well. 6 plus the square root of 96. If I don't arrow out from underneath the radicand, the parenthesis will be under the radicand. I need to use my arrow key and get out from under there and then close the parenthesis. Divided by 6 equals 2.63. I'm going to use my re-entry button, and I'm going to call the whole thing back, and then I'm going to punch in the minus sign. There we go.
Wait a second.
Minus would be negative 0.63. Is that better? Okay. Example 7, solve equations by finding their intersection. So you go to the math button, math, and I'm pretty sure that it's going to be under numbers. There it is, absolute value. You guys on the same page with me too? Okay. Absolute value of what? 2x minus 1, 2x minus 1. I'm going to arrow down to get out to the next line, y2. So what we did was we did y1 equals the absolute value of 2x minus 1. And then y2 equals 6. We're graphing them separately. The equation, we're breaking it up into two different equations. This is the calculator. We broke that equation up into two separate equations, the absolute value and a horizontal line 6. And graph. I can find the solutions by graphing both sides of those. Where are they equal to each other? It says the absolute value equals 6 somewheres. Where are they equal to each other? These intersection points are where they're equal to each other. If we know what those points are, we're going to know what the solutions are to this equation. So we're going to go to calculate. So we go to trace. We're going to the calc button. Step 1. We graphed. Step 2. Now we're going to calculate and go to calculate, and it's going to be number 5, intersect. Where are they intersecting? The first curve is saying it's the absolute value. Fine. Yes. Okay. And you want to be on that place where you think it is. There's where the intersection is. So I'm just making sure that my cursor is on the place where it is, where the intersect is. You can always tell which function you're on by looking at the top. Now it's on the y equals 6. I'm going to hit enter. And it's like, okay, is your second curve the absolute value? And it is. The second curve is the absolute value. Hit enter again. Is that your guess? Yes. And then it tells you exactly what that intersection is. Negative 2.5. X is negative 2.5. This is the answer. Answer. So x equals negative 2.5. And we need to do intersect again to get the other side. So intersect doesn't ask for left bound and right bound. They ask for the two functions. Calculate. Number 5. Scroll over until you get onto where they're intersecting on the right. And they're going to ask you about the two curves again. What are the two curves that you want me to find that are intersecting? Mine says absolute value at the top. You might say the other one, which is fine. I'm going to hit enter. Yes, that's the first one. And then when you hit enter, the other curve should come up. Enter, enter again, and we get 3.5. Those would be the solutions to this